So this week we're going to look at our Node MCU, so the ESP8266, and there was a whole bunch of documentation that you have to follow in week 8 to essentially download AT firmware into this guy. So this is your Node MCU. And again, the ESP8266 started life kind of as a Wi-Fi module for other microcontrollers, and we're going to use it in that mode. They've updated the software on numerous times over the years, and they have, depending on your device, they've added things for Bluetooth, for instance, on the ESP32 devices. This one that you have there is in ESP32, and so we are going to use that in the coming weeks. But just putting in the AT firmware, we're not going to be using it in Bluetooth, so we're going to hook up in there. So the very first part of that lab document is all about putting the ESP32, let me just see, there it is there. So this is about going and getting the AT firmware, and sometimes it's a little confusing as to exactly where it is. And I searched Espressive AT 2.0 firmware. It will give you the same list of binaries. There's just slightly different. You'll see Espressive, it'll say version 2 or not. Just slightly different formatting on some of the documentation. And so the whole first part of all of this is getting that firmware put inside. So once we have that inside, then normally what you would do is you would hook this to a, let's say your ST board, and you'd be able to use your ST board to talk to the Wi-Fi modem and go out and communicate with other things. I want to start off with saying, okay, let's use the AT commands and see what kind of things are supposed to be there. And we have a whole bunch of networking things to talk about in the upcoming weeks, but we'll start off with just putting a TCP server and opening up a TCP connection and sending just a simple hello over to the unit. So we're going to use that. Now, because I'm not using my ST board, because I don't want to complicate the programming with it, I want you to just to type things in. What we're going to do is use this module as our serial to USB translator. So we get the ESP32 out of the picture. So we hold it in reset, which puts all the inputs at high impedance and gets them out of the way. So essentially, we're just using the USB to the serial converter on this chip. Okay, so that's the whole point of the way we're hooking it up. Now, one of the things that it says when we go through this document, that's under the week 8, goes all the way down, how to flash the firmware of your ESP8266, wiring it up, this reset to ground on the LoRa module, which is, if you look here, there's our ground and there's our reset, just a wire between, keeps the ESP32 out of the picture. So we're just going to use the rest of the circuitry involved in it. Okay, so that should, I think, are you doing something with a FTDI module with Wayne? No, he hasn't mentioned it? Maybe, no. Okay, it would do the same kind of thing with another module, but you already have these in place. Okay, so once we have that all set up, and one of the things I've said is, and in fact, I've plugged it in here, so I can't plug both in at one time. If I'm plugging this in to be my USB to serial, I'm then going to use the 5 volts that comes off the USB to power the Node MCU board. And so I want to make sure that because I have a line going from my 5 volts over to here to power up this board, then I don't want to plug in USB here and USB here, because both of those 5-volt regulators are not going to like you backfeeding 5 volts from one another. So if I was to plug these in individually, because I wanted to look at maybe some output, I'd need to make sure that they were powered individually and just had a common ground. Okay. So that's the way we have it set up. And then if I plug in here, I should be able to send the AT commands that the expressive module is going to want over on here. And that's kind of the lab is going through that and making sure that we have things hooked up. So I'm going to hopefully show off some of the stuff here. Now the software under Windows that would be good to use is Terraterm. And so let's have a look here. Serial port. Looks like it's COM3 or COM11. Let's see what I've got. Might be COM11. All right. Oh, not all the way in. There we go. Don't think my USB was plugged in all the way here. Come on, shut down. Okay. So that's what I'm hoping to get. If I go AT and talk to this thing, then I should get this talking to my keyboard, going through Terraterm, talking to the ESP32 device. The ESP32 is out of the picture right now. And basically, we're just forwarding off to the transmit and receive on this module, and we're talking to it. So it's responding back through the USB to serial, going through and saying, okay. And then one of the things we can do is we can say AT plus GMR, which is going to talk to me about the version and things that are there. So it's telling me it's version 2.21, when it was compiled with the SDK and what version it is, and the binary version. And of course, it's the room. And I said that's the one you need to go and find. There's another module called a rover, which has some different size of flash chip and a little bit bigger pinout board, but the ones that we have are for the room. So if I have that all going, then I know that I've got the firmware flashed all right, and that I've got my connections all right. Some of the issues sometimes are if the transmit and receive line are backwards. We'll need to talk about serial a little bit more, because that's a common problem sometimes with this as well. And that we are at least responding to our AT set. Now, one of the things I said, if you've got that going, one of the other things that you can go and try is if AT plus GMR works, try AT plus CW lap. And there's, on the Espressive site, there's the whole documentation for all of this, and we'll have a look at that in just a minute. But AT plus CW lap, so if I do that, and I go AT plus CW, LAP stands for list access points. And so it should be going out and looking to see what routers it can find here. So here's all the different networks. So there's a Linksys router somewhere here. There's the Camosun guest, a couple of different EduRoams, and another Camosun. So there it's giving you, for instance, the MAC addresses of all the different ones. And the channels that they are on kind of as well. And so we have all of that going. So I could then go and join an access point, join one of these and connect up. Now, what we're going to do is in the lab, we have a router just kind of set aside from the college's EduRoam, which just needs your name and a password, or a name and password. So Bakery 204 is in 204 is the router. and then you put in the appropriate password. Everybody will have the same thing, and you'll connect up to that router. Or at home, you hook up your home Wi-Fi. So what I want to do on here is just to get around the college's stuff. I'm not close enough to the bakery router, is just turn on an access point, hopefully here. Okay, so I want to go, well, it says an IP, but let me go AT plus CWLAP. Um, now where is it? Okay, it said join, but let me just go to a lab. And it says, follow the AT documentation to get set up and required. So we have AT plus GMR and software. It says using the TCP IP AT examples, example one as a guide, connect to a packets server, TCP server on someone else's computer. Send a hello from your first name to the server, receive from the server, received by server's first name, and upload a screenshot of the send and receive packets. So I need this thing called a packet server, and actually there's a package called packet sender that you can go and download. And one of the options, you can download a packet sender as portable, and I like doing the portable ones anytime you can. You can install it system-wide in your system, but portable keeps it in a directory, keeps all the things configured with it in its own directory. So packet sender is one of the nice tools to use. And right here, it tells me what IP I'm at, but I want to be on the same network. So if you're doing this in the lab, you need to make sure that you're connected to the same router that your module is. And if my module is hooked up to the bakery router, then your desktop needs to be hooked up to the bakery router. Now, typically that's involved. There's two connections in the wall beside the computers, and one says L on it. There's the regular one, and one says L. And L is local and connects to the bakery router in 204. Okay, so if you hardwire into 204, and then you are Wi-Fi connected into to the bakery router, then you're on the same network, and you should be able to see your devices. And so I want to do that here. And so I'm just going to connect up and see if I can find me. Oh, there we go. Hopefully. Okay. And so this should give me whatever my machine is that I'm running this packet sender on. And so let me go back over to TerraTerm, and I'm going to go AT plus, oops, that might mess up. Oh, yeah, AT. Okay. So looking AT plus CIFSR, this is all in the documents that it has for us. It says, hey, my station IP address is 192.168.43.78, and it's also got a MAC. Now I can set this unit to be just a node connected to a router, and that's what I've done just here. You can also set it up in a mode to say, hey, you're also going to be give out IP addresses and be a router, and so you can set it up like that as well. And so we'll talk about IP addresses and MAC addresses and things like that down the road. Now I want to look at, it said example 3 in the document, or sorry, example 1 in the documentation under TCP/IP, and it's right here under ESP AT Users Guide. And then if we go to different AT command examples, then there's TCP/IP AT examples. And then example 1 is ESP as a TCP client in single connection mode. So I want to go there. And so it says, hey, go AT plus CW mode equals 3. So it says set it up as both an access point, a router, and a station. So it can be dual mode as well. So it could get, depending on what else you do with it, it could have things connect to it, or it could go and connect to a router. To join an access point, I did AT plus CW lap, which is list access point. To join an access point, I do AT plus CW join access point, or JAP, and it equals your SSID. So in our case, it would be bakery 204, and then common, then in quotes again, the password, and I'll write it down on the board for you. It used to be easy. It used to be just like bakery 204, electronics 204. Minsu changed it to capital E electronics at 204, capital C Camosun, capital C College, I believe. So it's harder to remember, but you have to put all that in the password. It should come back with response okay, or it could say, I didn't quite get that, I didn't quite understand it, so either the password is wrong, it couldn't connect in some kind of way. If it did connect in some kind of way, then when I do AT plus CIFSR, what that does is it says, hey, here's your address. If it comes back and it says 0.0.0.0.0, it didn't connect to an access point yet. So you need to go back and go AT plus CW join access point in order to make that work. So looking at that, so that takes us down to 3, where we queried the device's IP to find out what it is. And then it says, connect the PC to the same router which the ESP is connected to. Use a network terminal on the PC to create a TCP server. That's that packet sender that we're going to look at. And so I download Packet Sender, I install it, and this is what comes up. Okay, and so one of the things is the software, the AT software, can only connect to what's called a port that is 4 digits long. Okay, and so it'll give you all sorts of errors if you don't. And we'll talk about ports and addresses and all the rest coming up. But you see here it says there's a UDP, and that gives you the port for UDP. And here's TCP, and it gives me a port, and it's above 4 characters. So I want to enable it. And then we need to go in and set up that. So we'll go Tools, where is it here? Settings, Enable TCP servers, and it says, hey, server port or 0 for random. Well, it randomly picked a port that was too big. Ports can be anything above 1024, okay? But you need 4 characters in this because my AT unit won't do past that, okay? And so I could pick something like 7777, for instance. So it's 4 digits, and we'll just go okay. And now I'm TCP 7777. Okay, so this server is going to sit, and it says, hey, make sure that it stays persistent. So I see this little persistent button. I just want to click on that and say that it's persistent. And that means I want to keep the connection open for the time I'm playing with this, because it takes me time with my fingers and stuff on that. I don't want anything to time out and it lose the connection. So we have this sitting here, and it's at IP 192.168.43.54. It's on port 7777. So that's sitting, waiting, listening at a certain address for communications. Standard port numbers, for instance, web pages. There's a server sitting on a server listening on port 80 for web page requests. And then it will spin that off and respond to you. Okay, so I'm sitting waiting on address 7777. So let's go back to this document here, and it says, okay, connect to the PC to the same router which ESP is connected to. And it says this AT plus SIP start, and then so I want to make a communications, and your options here are TCP or UDP. TCP is a connection-oriented communications. It makes a socket connection, and you can respond back and forth over it. And there's error checking, and it's a lot more overhead than, for instance, a UDP packet. A UDP packet, I send a packet and I forget about it. And I can't guarantee whether it got there. If you want to get there with a packet, there needs to be some, your application needs to decide what's going on with it. The internet protocol won't do that. TCP, if there's missed things, the TCP protocol says, hey, I missed this bit of information, please retransmit it. The protocol deals with that, your app doesn't. UDP, it's just like, I sent you a packet, I don't know if it got there, I don't care, and a lot less overhead as far as the protocol goes, but then if you care about it in your application, you would have to deal with that. So two different ones, and we'll get into that in a bunch more detail, like I say, coming up. But I want to start a TCP because that's what example one does, and I want to send it to whatever my address is and whatever my port number is. And so if I go back to, let's just move that up a little bit because that's what I want to fire up here, and let's have a look at TerraTerm. And it says, okay, we do AT plus SIP start equals, and then I want this to be capitalized in there. I'm not sure if it will like it if it's not. And then I want to go quote, and where do I find the address? Where am I sending it to? So I want this is sitting on my laptop at 192.168.43.54. So 192.168.43.54, and then it wants the port number. On what port number were we sending things on? 7777. So then I go 7777. Okay. So what it did was it popped up this. It says 7777. Okay. So that means the connection's been made. I wanted a persistent connection, so it kept the TCP open, and it said somebody's connected to you on port 7777. And then if I go back here, it says, okay, to send data, you have to know how much you're going to send. Set data length, which will be sent, such as 4 bytes, enter the data. And so AT plus SIP send, for instance, equals 4. So I need to, how many characters? And so if I say HI space FROM space MEL, so that's 11. Okay, so then I will go AT plus SIP send equals 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I get hi from Mel. Let's open that one up here. Okay, over on this side, then I could go and it transmits back. Okay, so we've got socket communication, two-way TCP communication going from our um, node MCU with the AT firmware. And so we set that up and talk with the keyboard. So it's when I'm on the server, this should be, for instance, in the lab, somebody else's packet send server set up, and then you send something over to them, get a screenshot from them that says it's from you, and then they'll respond back and get something from your Terraterm here saying where it's coming back from. Okay, so that's the back and forth communications between the two. So that shows that I'm able to go and have a network connection. I'm able to send data over the wire, and this module is then set up for AT firmware. So the next lab, when we go and use it and hook it up to a microprocessor, that it is properly communicating. Now, one of the things, well, let me just see about, I'll close. I can either do on this side AT plus SIP close, which will end the communications, or over on this side, I can go close. It should be AT plus SIP close, I think. Okay, and then, so it will just close the comms. Now, if you look on the documentation for the AT communications, it says AT command set. It's got a bunch of samples, and it breaks it down into basic AT commands, Wi-Fi commands. So we can set up a server. You can have a small web server, for instance, on it. Or you can do TCP/IP commands, what we just did. You can send TCP or UDP communications for the ESP32, which again is one of these that we're not using in that mode right now. We're talking to this one. You can actually also connect and send Bluetooth communications as well. We will be talking in the coming weeks as well about MQTT. MQTT is machine-to-machine communications. It's a very lightweight protocol for being able to send data over the wire. So if I had a bunch of sensors throughout my house, for instance, a lot less overhead than sending just web packets or something like that, like HTTP. Being able to send MQTT is very small and not expensive as far as let's say I have battery powered devices or something like that. But you also can do web server stuff. That's all the HTTP things as well. So it's broken down into all sorts of these different ones. There's also a PDF version of this that's available that you can download as well if you want to find out some of the commands. For instance, if I go and look at the basic AT commands. And typically it's AT plus that you will go and use. Yeah. See, this should be working because it's my, go there. Oh, not there. Um, see, I was wondering about my Wi-Fi. So there's the PDF that I downloaded of that. And so it's showing you all the different things, basic AT, Wi-Fi AT commands. If I go to basic AT commands, so any of these you can type in AT. Uh, you want to look at, for instance, local time. AT plus RST is like hit and reset or repowering up. Just AT by itself. If things are messed up and keep giving you error, go AT till you see OK, for instance, in that. And so there's a whole setup and showing you what kind of things to expect in response. In the document, it also shows you how to hook up various um, parts to this. One of the things is we're basically using your ESP32, using it as just a USB to serial interface. There also is data that comes off of the USB connector. It's mainly logging info or different things to tell you how this thing is responding that comes off here. But again, if you had plugged this in, you can't power it up with the 5 volts going over from here. Okay. One other thing to point out with these is both of these are powered by USB, so both of these are powered by 5 volts. The chips themselves are 3.3 volts and do not take kindly to 5 volts. Okay, so there are 3 volt regulators, 3.3 volt regulators on both of these to power up these individual devices. So you have to be careful in what you can't just apply 5 volt things to them. Okay, and so all of my different pins and interfaces and things would be over to 3.3 volts. Any questions on that? Back up and going with this. AT commands. Wi-Fi AT commands. The type of things that you get, AT plus CW JAP, connect to an access point. AT plus CW LAP, we looked at, list different access points. Obtain an IP address of a station, AT plus CW LIF. For instance, if things are connecting and you want to find out what IP address it gave you, have DHCP. So if I'm set up, I have to be set up in the server mode, that's AT plus CW mode equals 3. I can actually enable a DHCP server and have it hand out addresses. It's a small unit. You couldn't have more than 1 or 2 devices connecting up to this at one time with what is currently there. Okay. Now, one of the things, let me go back. Where am I? There we go. AT. Now, 2 things that were given here when I go AT plus CIFSR is our station IP. And so that's me connecting to my phone or up in the lab, you would be to your bakery router to see that I'm on the same network. Okay. And so my phone is handing out 192.168.43.78. As far as a MAC address, my device is got in here a hardware address, MAC address. You might hear it referred to as a NIC or network interface card address, is F4CF82EF94C1. Now, when they first started coming up with networking, in order to communicate with different devices on a network, they had this media access control or MAC address layer. And so it was a 6-byte address, and it's known as a flat file addressing. So the first 3 bytes were known as the organization unit identifier. The last 3 bytes were supposed to be just for the individual card, network interface card. And so as long as that's unique, it was supposed to be unique worldwide, but as long as it's at least unique in your network, then I'm able to tell one machine from another. But one of the problems, and when it first was just a network in just a single location, then that was great. But then, for instance, the first 3 bytes are the organization unit identifier or the manufacturer. So if I bought a network card from a company like 3Com or Linksys, those first 3 bytes are kind of the same. In fact, those companies have several different ones of those. But And you have if you have a program, for instance, like Wireshark, it's able to decode that, and it'll actually tell you, oh, this is a Linksys card, or maybe this is a Microsoft, or this is a microchip, or anything like that. And then you have the individual identifier for the card. Years ago, when we were first doing some of this, uh, even though they're supposed to be unique, you could get network cards, cheap network cards, for instance, from China, and all the Macs were the same. And so in one network, what would happen is when the system fired up, it would ask the DHCP server somewhere with dynamic host control protocol server, and it would say, give me an address. And it would look at the MAC and hand out an address. And then another network card would fire up with the same identifier asking for an address. And so in the lab, before we figured what was going on, you'd get people firing up things, and then you'd see something on a web page, and then you'd go refresh, and you'd see something that somebody else saw on a web page, and it would get all kind of confusing because they have to be unique. I have to know that what you're requesting is come from you, so I can send you back the data. Okay. The problem, and as long as these are unique, that's awesome. I know who's asking me for stuff. And as a router, I can go and ask the world for things and make sure that you get the information you ask for. It all goes through the router. The problem with a MAC address is it's a flat file system. So I could buy a card from Linksys, and I have F4C, FA2, EF94, C1, and somebody in Australia could buy a card, and that might be sold to them from Amazon, and it's C2. And so I can't tell by the MAC address where in the world it is. So if I was to keep track of this and anybody needs to communicate to anybody, I would need, billions of MAC addresses in my router to figure out where things are. So it doesn't really scale that well. And so we have IP addresses to go above that. And so that's where I have the IP address. And so the thing about an IP address is routers will know the IPs of the router, and anything addressed to it will say, if I want to send to 192.168.43.78, all the router has to do is know what network it's in. And let's say it's 192.168.43. 78, 77, 76, anything in that kind of range, perhaps, is a node or an endpoint in my network. So the router just has to keep track of, for instance, maybe 192.168.43. That's classically called a Class C network. And so it's just saying Class A was first character, first byte. Class B was 2 bytes. Class C was 3 bytes. And so if I have a Class A network, then there's a whole bunch of different nodes that I can have. A Class B is half and half. A Class C, there's 254 different nodes that can be in that network. We'll talk in detail a little bit more about that. So if I want to get past my network and I want to send stuff out in the world, when I send stuff out in the world, different routers talk to other routers, and I will say, for instance, let's say if I'm going to want to go to 4.ca. So when I type in onto a web like Google and I say up at the top, I want to go to 4.ca, how does it get to Ford? How does it know where that is? Huh? DNS. change your name to an IP address. So DNS. So there's a DNS server. The college has a DNS server, and it looks up and says, "Hey, where's 4.ca?" And it will cache some of the local ones. And if it doesn't know it, it'll ask a DNS server at the IP. And so somewhere there's a resolution to take the name to the number. So now I got back and I've got 4.ca, and it is let's say 4.ca, and don't quote me on it, but let's say it's 172.40.40.5. How does it know where to go now? We've turned 4.ca into 172.40.45. How does it know it's not here? Okay, I like. So mine is 192.168.43.78, and they're kind of different. How do I know it's not in my network?
It'll send it to your access point.
It'll send it to your access point. The network mask tells me so a typical mask is 255.255 in class C, .255 class C or slash 24. Okay, that's a class C. So these are ones and that's a zero, and we AND them. And whatever comes through says my network is 192.168.43.0. And so I said there was 254 nodes. All the zero is the network. So this is my network's name. All ones, or 255, is broadcast on that network. So if I want to send stuff out that everybody in the network hears, it's all ones. So I have my 256 minus 2 left. Okay, not the zeros, not the ones. So that's my network. So the mask tells me that's my network. Is this in my network? No. So I send it out to my gateway or to my router and say, I'm looking for this. It's not in my network. So please find it. And it will go out and say it may know it because somebody else looked at Ford recently. So it might be in its cache. And if not, it will go and talk to another router and say, hey, do you know where 172 is? Now, the thing about IP addresses is they have a hierarchy to them. So there are certain IP addresses that are in Australia, certain ones in India, certain new, very young into the companies like AT&T and Apple, and a few have, less than a class C. They might have class A's. All of AT&T and things, and some countries and things have class A or a /8 is that, and they have that many hosts, which means I can start carving those up and sub-leasing them to other companies and things. But for now, it's not in my network, so I send the request to the router. The router goes and says to other routers, where is it? Because it's hierarchical, different servers go, oh, I don't know where this is, but I'll send it to the server over, or to the router over in Australia or in Europe or wherever, and they'll ask other routers, and then it comes, let's say it's coming in from somewhere else, and it goes to Camosun, and then they say, hey, 192.168.43 or something, do you have one of those? And it doesn't ask for the individual nodes, it just asks for the network. Camosun has, I don't know, 4 or 5 different networks. And so it has 4 or 5 entries in the router. Yep, it's one of mine. Doesn't necessarily know whose it is, but it goes and sends it to that network. And then whether it's electronics, or it might be over in business, or it might be wherever. And then it says, it's got an IP address, and it says, broadcast out to that network, who is .78. And then I will respond back, if it's me, with the MAC address. And then you will send the data with the MAC address local to this network. MAC addresses can't get past the router. I am being used to send data at this low level. Okay, we use an IP address to get to the next level and continue on. Now, we did something else there with one of these. What else did we do when we connected? We sent TCP. I said TCP was this connection-oriented thing. And then we also sent, there was UDP, which was this connectionless. But what other thing did I send? Yeah, the port, 777. 7777. Okay, so I could have multiple things happening at the same time, and how do I distinguish between different things? When you're on for instance, uh, how many tabs do you have open on Google, for instance? And it doesn't mix up the pictures between one tab and another. It knows which one is going to which place. If I was downloading multiple files, it doesn't interchange them because each one is at its own port number. Okay, it's able to keep the streams of data separate. Okay, and so that's the port. And then if I look over here, for instance, it's showing me a little bit about my communications, and it says when I did this, it says, hey, I connected to port 777 TCP. I sent hi from Mel. There's the actual bytes that it sent. And in fact, we can look at a UDP packet or a TCP packet and see where exactly all of that comes from. And then we responded back and it said hi from the laptop. So this is hi from the laptop, again, TCP. And I sent back to the address of this guy, and it's port 63893. It picked, when I sent here, I sent to the server where it was listening. And when I sent, I had a random port number above 1024. And then it's that my IP address and my random port number plus this, the receiving IP address and the receiving port 777 makes a socket connection. If I left this open and made another TCP communications from it, as long as I had the RAM and the device to do it, it would be the same IP address, but it would be a different port number going to the server address 777. Okay, so they're unique addressing, a unique socket connection. Okay. We'll talk lots more about networking coming up. Hopefully everybody gets the lab going like we saw here today.